Let's solve question number 16, guys. The major product in the following reaction. I strongly suggest that before looking at the options, you solve this question and then you look at the options. It becomes a little easier, guys. Okay. So what you're doing, you're adding a tertiary butyl alcohol and heating this. Okay. So what will happen? Elimination is going to take place. What will take place? Elimination will take place. So first you'll remove a I minus from here. So as you remove a I minus, what you will get? You will get a carbocation. What you will get? You will get a carbocation. So here you get a carbocation. So there is a hydrogen, guys. There is a hydrogen over here, right? So what will take place? 1,2 hydride shift will take place, because if you are shifting it, you are getting a more stable carbocation, right? So if you shift it over here, that is a hydride shift. So what do you get? You get a more stable, carbocation. Okay, so this is, here you get a positive charge now. Okay, and here you have a bond. Okay, now what would happen? Here we have two options. Here we have what? Here we have two options. You can remove a hydrogen. You can remove hydrogen from where? You can remove hydrogen from position A, and you can remove hydrogen from position B. So it will follow what? It will follow Sedgwick's rule of elimination. And if it is following Sedgwick's rule of elimination, then you will remove hydrogen from where? You will remove hydrogen from B. You will remove hydrogen from B. Therefore, your product would be what? Your product would be, right? Okay. So the answer is what? The answer is option 3, guys. Well, a very simple question, just that you should be aware of 1,2 hydride shifts. If you are able to make that happen, then you can solve this question, guys. Okay. I hope this question is clear. Let us go on to the next question. That is question number 17. So here what we have, it's a question from states of matter. A mixture of 1 mole of each, hydrogen, helium, oxygen, each are enclosed in a cylinder of volume V at temperature T. If the partial pressure of hydrogen is 2 atmospheres, the total pressure of gases in the cylinder is. So before we look at the options, I think let us jot down the data, guys. Okay. So what we have is, we have hydrogen, helium, and we have oxygen. Number of moles, 1, 1, and 1. What they have given? Pressure is how much? Pressure is 2 atmospheres, right? For hydrogen, the pressure is how much? The pressure is 2 atmospheres. Okay. If I'm talking about the same conditions of temperature and volume, so if 1 mole of hydrogen has a pressure of 2 atmospheres, then 1 mole of helium will also have a pressure of 2 atmospheres. 1 mole of oxygen will also have a pressure of 2 atmospheres, right? So pressure of both will be 2 atm and 2 atm. So the total pressure becomes how much? So if you are looking at the total pressure, so total pressure becomes how much? The total pressure is 6 atm. Pressure is 6 atm. Therefore, the answer is option 4, guys. I hope you have understood. This is a very simple question, guys. Okay, not at all a difficult question. Okay, so that is your 4 marks. Okay, let us proceed ahead, guys. Question number 18. The compound A in the following reaction is. So this looks like a mixture of all the reactions, guys. Let us try and understand each and every reaction very carefully. Otherwise, there are always a chance over here that you may make a mistake, guys. You have to identify A, guys. We have to identify what is A. So with Grignard's reagent followed by Conc H2SO4, it is giving you B. B, when treated with O3 in presence of zinc H2O, so you're carrying out reductive ozonolysis, you're getting C and D. C with Conc KOH is giving you potassium benzoate and benzyl alcohol. D with barium hydroxide is giving you a alpha beta. It is giving you alpha beta unsaturated ketone. If you observe last reaction very carefully, what reaction is this? This is your aldol condensation. What is this? This is aldol condensation. Can I predict the starting material over here? Can I predict what is D, guys? Can I do that? Let's try that out. I break this bond over here. I break this bond. Okay. On one side I put oxygen, on the other side I put a H2. On one side I put oxygen and the other side I put H2. So what do I get? I get CH3C double bond O CH3. So this is your compound D, guys. This is your compound D, right? So if I observe this carefully, this is undergoing aldol condensation and giving you this product. Yes. Now let us go to C, guys. What reaction is this? C is reacting with KOH, and on heating it is giving you potassium benzoate and benzyl alcohol. This is a familiar reaction, guys. This is Cannizaro's reaction. What reaction is this? This is Cannizaro's reaction. Right? So if you're talking about Cannizaro's reaction, what is the starting material? What is the starting material of Cannizaro's? It is a aldehyde without a alpha hydrogen. It is a aldehyde without a alpha hydrogen. So here the aldehyde should be what? The aldehyde should be benzaldehyde. So we have discovered what is C and D. Now we have to convert C and D to B. How am I going to do that? Let's see. What is our C? C is pH, CHO, and D is what? This is your D. Very simply, guys, do one thing. Remove the oxygens, put a double bond. Remove the oxygens, put a double bond. So when you remove the oxygens and put a double bond, what do you get? You get your B. So B is so we have got the compound B, guys. Now let us look at the option. So from where can we get compound B? Okay. So here if I look at all the options very carefully, if in this case if I add CH3 MgBr, so what will I get? I will get C6H5 COH CH3 CH2 CH3. So this does not satisfy the compound D, guys. This does not satisfy your compound D that we are getting. Okay. Now let us look at the option 3, guys. Let us look at option 3. To this, if I add CH3 MgBr, right, so what do I get? I get C6H5 CH2 COH CH3 CH3. Now this compound, if I treat it with H2SO4, so what do I get? I get C6H5 CH double bond C CH3. Isn't this compound your compound B, guys? Yes or no? That we have discovered over here. Yes, isn't it? So what is our answer, guys? So what is our answer? So the answer over here is option 3, guys. Okay, so I hope you have understood this very tricky question, which was a little tough, I'll say, because it was a mixture of all the reactions of aldehydes, ketones, guys. Okay, let us proceed to the next question.